This lesson is about the volume of cylinders, cones, and spheres. So some basic vocab that we need to know to be able to do these. First is you need to know the radius. A radius is the straight line from the middle of a circle to the outside of the circle. So there's the belly button, goes out to the edge, that's the radius. Diameter is a straight line that goes through the middle of the circle. So it goes from one edge to one edge and it goes through the middle. If you have the diameter and you cut it in half, that will get you the radius. Vice versa, if you double the radius, that will give you the diameter. So they're very related to one another. Next one is height. Height is the change in altitude of an object that's when put on its end. So I drew a little itty bitty cone here, and if we think of a cone as going up, the height is from the base to the top of that very point. Now on this object, I've turned it sideways, but don't get confused. The height is still the distance that goes out. So if you turn it up like this, the height would be going up and down like this. So this edge right here is the height, because if we return it, that would be the altitude change. The next one is pi. Pi is the ratio used to calculate dimensions of a circle. So we all know about 3.14 blah, 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 blah. That's what we use for calculating distances in circles. The next one is squared, when a number is factored twice. So 2 squared means that we're using two twos, so 2 times 2. Cubed, the last vocab word, is when a number is factored 3 times. So 4 to the third power, or 4 cubed, is 4 times 4 times 4. All right, very important concept number 1 is finding the volume of cylinders. So I've given you 2 examples here. We have one cylinder that's on its end. The circle part is down. The radius is 6, and the height, the up and down, or the change in altitude, is 4. So we've got our formula. The volume of cylinders is pi times radius squared times height. If you substitute those numbers in, the radius is 6, so 6 squared, and the height is 4. So pi, if we square 6 times 6 is 36, so I've brought that down, and then I've multiplied all these together, that equals 452.4. In the next example, I've drawn a cylinder on its side. To help you see which one is the radius and which one is the height, picture it going this way, so that the circle is at the base, and this would be the height. If that's the case, 7 is how tall it would be, and 2 would be the radius because it's part of the circle. So, same thing using the formula, pi r squared times height. Pi and the radius is 2, so 2 squared times 7, which is the height. So pi times 4, because 2 times 2 is 4, times 7. And then when you multiply that out, you get 88. Very important concept number 2 is the volume of spheres. Now spheres aren't quite the same size as cylinders, they're a little bit smaller. So I've got 2 examples here. We've got one regular sphere, and notice that I've given you the diameter, not the radius. The radius would be half of this diameter, which would make it 5. It's kind of a trick question, and you have to be careful to look for it on standardized testing because they'll try to trick you into thinking, oh, do they know the difference between radius and diameter? So, the volume of spheres, the formula is 4/3 times pi times radius cubed. This is the only formula that has radius 3 times. Substitute the numbers in, 4/3 times pi times 5 cubed. Again, 10 is the diameter, 5 is the radius. And then 5 cubed is 125. When you multiply this all out, you get 523.6. Now in this example, they've given you a hemisphere. So you have a sphere, hemi is half, so half of that hemisphere. So you take the same formula, but you're going to divide it in 2 because you're dividing that sphere in half. So 4/3 times pi times radius, which is 6 cubed, divided by 2. When I cube 6, that's 216. And when I multiply and divide this out, you get 452.4. Very important concept number 3 is the volume of cones. So when we poured the rice into the cylinder, the rice only filled up 1/3 of that cylinder. So when we look at our formula, we see 1/3 radius squared times height. Oh, I forgot pi. There we go. Of course you have to have pi. I wonder if this, I'll double check that calculation. So, fill in your equation, 1/3 radius squared times pi times height. So we've got 1/3, 4 is your radius squared, times the height is 10, which we've got, times pi. 1/3 times 16, because 4 squared is 16, times 10 times pi. And then let's multiply that out, clear on. We've got 1 divided by 3 times 16 times 10 times pi, and that equals 167.6. So that is the volume of this cone. All right, so you have some practice problems. It's a little different this time because I want you to do the practice problems and then answer them in your toolkit, and then I will have controls out in the classroom for you to use to check your answers.